multiply the top of the fraction and the bottom of the fraction by the same number. All right, so if you want to multiply the top of the fraction by 4, that's okay, as long as you multiply the bottom of the fraction by 4 also. You can multiply the top of the fraction by 16 if you want to, but the only thing is you have to make sure and multiply the bottom of that fraction by 16 as well. So when you do that, you keep the fraction in balance, and that's how you make them and see that they're equivalent. So let's do an example to show you exactly what I'm talking about. So let's draw a picture of the most famous fraction of them all. Here's our pi, and here we've cut it exactly into 2 pieces. So let me go ahead and shade this guy. If this is the amount of pi that we actually have, what fraction do you think we have? Well, we have 2 pieces and a total, and I only have one of these 2 pieces. So this is 1/2. This is the most famous fraction of all, right? Half a pizza, half a pie, half of a peanut butter and jelly sandwich, or whatever. All right, so let me show you something. What I can do is I can put an equal sign here. And I told you, I can take the top and bottom of this fraction and I can multiply it by anything I want as long as I do it to the top and also to the bottom. So I can rewrite my 1/2, and I'll just make a longer little fraction bar here. And I can multiply the top of this fraction by the number 2. But if I do that, I just have to make sure that I can also multiply the bottom of my fraction also by 2. That's very, very important for you to understand. I can multiply the top and the bottom by the same number. And if I do that, I'll change to another color here. What will I get? 1 times 2 is 2, and 2 times 2 is 4. Now this is absolutely crucial that you understand. When I do this here, when I multiply the top and the bottom by a number, then even though it makes the fraction look different in the end, it's exactly equal to the fraction that we started with. So that's something that you have to get used to seeing. 2 fractions can be the same thing, but they just might look different. In other words, 2 out of 4 pieces of a pizza is the same thing as 1 out of 2 pieces of a pizza. And to show you that, let's go ahead and draw this second fraction over here to take a look at it. So if we have this guy right here is our pizza. But see, now we're not chopping it into 2 pieces like before, we're actually chopping it into 4 pieces. So here is this guy, and here's this guy. If I chop it into 4 equal pieces, but now I have 2 of these smaller little pieces. So here is piece number 1, and here is piece number 2. So graphically you can see that this represents the same amount of pizza. If I'm at a party, or if I'm at a get-together, and I give you 1/2 of the pizza, 1 out of 2 pieces, it's exactly the same amount of pizza as if I give you 2 pieces out of 4 that I cut from a different pizza. And I think you'll understand that. If you picture a peanut butter and jelly, I cut it in half and I give you half. That's the same amount of sandwich as if I cut that sandwich into 4 pieces and just give you 2 of them. So the secret to this is understanding that you can multiply any fraction you want on the top and also on the bottom, as long as you do it by the same number, multiplying on the top as you do on the bottom. So one way to think of this, I want you to kind of think of a fraction as a seesaw, like a teeter-totter from the park. Okay, so here we have, it's balanced in the middle, okay? Over here is this thing, and over here is this thing. So, I'm sitting on both sides of the seesaw, and I'm perfectly balanced on the seesaw, all right? Now, everything is balanced. I can multiply this fraction by something on the top. But if I do that, I have to also multiply the bottom to keep it balanced, to make it equal to the same thing. If I start multiplying the top of this fraction by something and not doing anything to the bottom, then the fraction is no longer the same thing. So think of it as a teeter-totter. Everything's balanced as long as I do it to the top and also to the bottom at the same time when I do this guy. All right, so let's go over here and do another one that will continue to help us. Let's say we have the number, or the fraction, 1/2, all right? And let's multiply it by something different, just to prove to ourselves that it's the same thing. So let me rewrite this fraction again, draw a little bit of a longer fraction bar, and in this case, I don't want to multiply by 2, I'm going to multiply by 3. And I said I can do that as long as I multiply the top and also the bottom by the very same number. So you see, I'm multiplying on the top and the bottom by 3. And when I do that, 1 times 3 gives me 3, And 2 times 3 gives me 6. So what I'm claiming here is that even though I've changed the way the fraction looks, in fact, they're actually exactly the same thing. They represent the same amount of pizza, or the same amount of cake, or the same amount of peanut butter and jelly, both of these two fractions. Because even though I did the multiplication, I did it to the top and also to the bottom. So to show you that, let's go figure this out. So this fraction is our famous 1/2, okay? And that would be this amount of the pizza. All right, and so let's go and draw this one over here just to see if it's right. And so the way I'm going to do that is I'm going to cut it in half this way, and then I'm going to cut it in half this way, and then I'm going to cut it in half this way. Now, as best as I can, I'm trying to show equal pieces. There's 1, 2, 3, 4, 5, 6 pieces, because this is out of 6 pieces, but I'm only actually having 3 of these pieces. So here's a piece, here's a piece, and here's a piece. And I think you can see by comparing these two fractions that this is actually half of the pizza. Even though it's 3 pieces out of 6, it represents the exact same thing as 1 piece out of 2. So you can't always tell, just by looking at the fraction, by just reading the numbers, you can't always tell if it's the same or different as another fraction. You have to dig a little bit deeper, because sometimes they can look different, but they can actually represent the exact same amount of pizza or cake or whatever it is you're talking about. All right? So what I want to do now is give you a little practice with this idea of equivalent fractions. And so I'm going to do a little problem here, a little fun problem. Let's say we have the fraction 7/10. This means I cut a pizza into 10 pieces, but I only take 7 of those pieces. And I'm going to have a question mark with an equal sign there, and I'm going to write some other fractions down over here. So let's say I have 1/4, 14 20ths, 3 21s, 21sts, 21 30ths, and 14 tenths. And my question is, here's the original fraction I have. Here is 5 possible choices. We want to circle the fraction that's equivalent to 7/10. We want to circle the one that's equivalent. So you see we have 7/10. All of these fractions look totally different than 7/10. But one of them is actually equivalent because of what we talked about. So the way you do this is you look at your original fraction. So let's write it down here. 7/10. And we need to figure out, we need to multiply the top and the bottom by something. And when we do that, it should equal one of these fractions on the other side. So all we need to do is figure out the fraction that matches up when we multiply this by something. So the bottom is the easiest thing. If I multiply the bottom times 2, what am I going to get? If I multiply the bottom times 2, then I also have to multiply the top times 2, and I will have 14, 7 times 2 is 14, over 20. And I look in this list, and it looks like I actually have that one right there, 14 20ths. So this fraction is equivalent to this one. It looks completely different, but that doesn't matter what it looks like. It represents the same amount of pizza. If I take a pizza, chop it into 10 pieces, and only take 7, it's exactly the same amount as if I take a second pizza and chop it into 20 pieces and take 14. All right? All right, now that we figured out that multiplying this fraction times 2 on the top and the bottom will give us this, let's just see if any of these other fractions can also be equivalent. Let's go and see. Let's take this fraction, 7/10, and let's multiply it, in this case, by 3 over 3. Let's just see if anything else fits. All right, 7 times 3 is 21. 10 times 3 is 30. So we go up there and we look and see right away that 21 over 30 is listed there as well. So this fraction, 21 over 30, is also the same thing as 7/10. Now, I don't believe there are any other answers that work, because if you think about it, you're multiplying by something on the top and the bottom, so it has to be a multiple of 10 on the bottom. So there's no other fraction that works. If I multiply by 4 over 4, I would have a 40 on the bottom. If I multiply by 5, it would have a 50 on the bottom, and so on. So there's nothing else in this list that works. But it's important for you to know that the fraction 7/10 is exactly the same thing as 14 20ths. which is also exactly the same thing as 21/30ths. They're all the same thing. If I take 3 pizzas and I cut them up and I can't hand out the pieces that way, then it's going to be the same amount of pizza for all 3 of these fractions, even though this looks totally different than this, which also looks totally different than that. So let's move on and do another problem. Let's say we have the fraction 3/8, and I want to figure out what is equivalent to that. And my choices are 1/8, 3/16, 6/16, 9/16, and 9/24. And I want to figure out what is equivalent. All right, so let's go and do that now. Let's say we have 3/8. Let's just start by trying to multiply by 2 to see if we can change this fraction. So we multiply by 2 on the top, so then we have to also do it on the bottom. That's the rule. 3 times 2 is 6. 8 times 2 is 16. So I look and see, do I have a 6/16? I have it right there. So these 2 fractions are the same, even though they look different. Let's see if we have any other matches. We have 8/3. That's our original fraction that we started with. Actually, it's not 8/3, it's 3/8. So let's mark it down as 3/8 is our original fraction here. And let's multiply it. And this time we multiplied by 2, so now let's multiply by 3, and let's see what we get. 3 times 3 is 9. 8 times 3 is 24. We look and see that we have 9/24. And those are going to be the only answers, because when I'm multiplying, if I multiply by 4 on the bottom, 8 times 4 is 32. I don't have any 32s on the bottom. 8 times 5 is 40. I don't have any 40s on the bottom. So there's nothing else that matches. But what this is showing is that 9/24 is exactly the same fraction as 6/16, which is also exactly the same fraction as 3/8. You can multiply a fraction by anything you want as long as you do it to the top and to the bottom at the same time. All right, so the final one that we're going to do, just to bring it home, is 2/3, and I want to figure out what it's equivalent to. So here we have 1/3, 2/6, 4/6, 4/12, and 6/9. And I want to figure out what is this fraction equivalent to. So I start with my 2/3, and I multiply this guy. Let's just start by multiplying by 2. That's the easiest thing to multiply. 2 times 2 is 4. 3 times 2 is 6, so 4/6. 4/6 is in this list. So these 2 fractions are equivalent, even though they look a little bit different. Okay? And let's just try, for giggles, we'll try 2/3, and we'll try to multiply by 3. We'll multiply by 3 on the bottom, 3 on the top. We have to do it in both places. 2 times 3 is 6. 3 times 3 is 9. So I go up there and I see, do I have 6/9? And I do. So that's equivalent. Now I can keep going. I can keep multiplying by 4, right? But let's just see. Let's just do it real quick. 2/3. If I multiply by the top by 4 and the bottom by 4, on the top I'll get 8, and on the bottom I will get 12. So I look for 8/12. I don't see it. I have a 4/12. That's different. That's not equivalent. If I keep multiplying by 5 and by 6 and by 7, I'm not going to have any matches here. So I'm done with that. So we can see here that these 2 fractions are equivalent to each other, and they're also equivalent to 2/3. This section, I really can't stress how important it is. Most of the challenge with fractions with people is that you can have 2 fractions look different, but they actually mean the same thing. And that, it shouldn't be hard. It shouldn't be a hard concept, but it can be for a lot of people. So we did the first couple of problems with the pictures to show you how it's true. The number 1 rule to remember is you can multiply the top and the bottom of a fraction by anything you want, as long as you multiply the top by the same number that you're multiplying the bottom. That keeps everything in balance. I'm Jason with Science